Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand scenario based troubleshooting for network engineer. So if you are a network engineer or if you are planning to become a network engineer, this video is only for you. Interviewer is also asking scenario based interview question in interview. So even if you are preparing for interview, this video can help you a lot. Or if you are a network engineer working in industry, then also this video can help you to troubleshoot OSPF network. As you know, most of the organizations are using this protocol, OSPF routing protocol, in their network. So if you are a network engineer in an organization, definitely sometime you will face some problem in OSPF. So this video will guide you to troubleshoot OSPF network. So here you can see ticket. I have 3 tickets. I am going to solve all tickets one by one. So number one is issue is PC1 is not able to ping PC2. Engineer configured OSPF protocol on all routers for reachability. That means between routers, router 1 to 3, we are running what? OSPF protocol. And as a network engineer, you need to troubleshoot that why PC1 is not able to ping PC2. So guys, I am going to troubleshoot this scenario step by step. Okay, first we will solve this issue, ticket number 1. So let me check first that am I reachable to my default gateway. First of all, here I need to configure IP. On routers, I have already configured IP address and OSPF. Just I am going to configure IP on PC. So 10.1.1.10/24 and gateway is 10.1.1.1. This is my gateway. Okay, so checking for duplicate IP address. Now you can see. Now let me check that am I able to ping my default gateway 10.1.1.1. So yes, I am able to ping my default gateway from router number 2 also. Let me check that. This is first step. First of all, whenever you will troubleshoot any network, first of all you should check the reachability to default gateway, right? So here also IP 10.1.2.10/24 and default gateway is 10.1.2.1. Step number 1 will be ping to your default gateway 10.1.2.1. Okay, from here also I am able to ping my default gateway, right? Means router 1 is also able to, PC1 is also able to ping their default gateway and PC2 is also able to ping their default gateway. Now I am going to check the existing configuration on these router, guys. Okay, like we are running which protocol? OSPF. So I will check OSPF neighborship first, that neighborship is working fine or not. So let me take you on router number 1. And here what command I will run? So IP OSPF neighbor first. So okay, neighbor is 2.2.2, priority is 0, state is full. On which interface? On F1/0. Okay, so neighbor is fine of router 1. Let me check the routing table. So IP route OSPF, because this router should have a root for 10.1.2.0/24 network. But here you can see this router does not have any root for 10.1.2.0 network. So that's why PCs are not able to ping. If you will verify it from PC number 1, let me ping PC2. Ping 10.1.2.1. Yes, you can see I am not able to ping. So my traffic is actually dropping on which router? On router number 1, because router 1 does not have any root. Now what I will do, I will check the database of router 1. So let me check in the database router have this link information of this link which is running on router 3 or not. Actually OSPFs here LSA. So I am going to check the LSA, that router 1 have LSA for this network or not. So IP OSPF database. So yes, you can see router LSA. There are 3 number of router LSA. 3.3.3 is also advertising, 2.2.2 also advertising, and 3.3 also advertising. Now I am going to open the LSA 1 of 3.3.3 in detail, because here we need to troubleshoot that why router is not installing this prefix 10.1.2.0. So can I open it in detail? So IP OSPF database router 3.3.3.3. This is the command to check the detailed information of router LSA. Okay, so here you can see this is the header. After that, link connected to a transit network, that is 23. Okay, and link connected to a stub network, that is 10.1.2.0. Subnet mask is this one, but router is not installing it in their routing table, right? So in the database you are able to see, but where is next hop IP address? I'm not able to see any next hop IP address. If you will check the database of 2.2.2, see, like 2.2.2 is advertising which network? 23. Yes or no? And this one, okay. So here also you are not able to see any next hop IP address, but 23 is available in the routing table of router 1. So IP route, but 10.1.1 is not available. But in the database you are able to see the link information. Okay. So on router number 1, I think everything is perfect. Just now I am going to check that how many command engineer have run here on router number 1 in OSPF. For that I can run command so run section OSPF. Guys, if you will run section router OSPF command, then it will show you the all commands which you have run in router OSPF. And if you will filter like this section OSPF, it will show you the all commands of OSPF. So here engineer have configure IP OSPF network type point to point. Okay, I think on F1/0 link is point to point, router ID is 1.1.1 and network is 0.0.0. Okay, now I am going to check the network type. I think because here you can see the network type is point to point configured on F1/0. By default network type on Ethernet link is broadcast. So IP OSPF interface F1/0. Here network type is what? Network type is point to point. Okay, and on 0/0 F0/0, here you can see the network type is broadcast. So by default on Ethernet link OSPF network type is broadcast. So engineer have changed the network type on F1/0. Okay, to avoid the DR and BDR election here, because DR and BDR is not required. Now on router number 1 I am fine, everything is fine. Now let me take you on router number 2. Here I am going to check first so IP route OSPF. So in the routing table of router 2 you can see 10.1.1.0 is there, but 10.1.2.0 is not there. Now let me check the neighbor. So IP OSPF neighbor. So okay, neighborship is fine with router 3 also and with router 1 also. State is full. Okay. So IP OSPF database. Now let me check the database. In the database also you can see there are 3 number of LSA1 and there is one LSA2 as well. Who is advertising this? 3.3.3 means router number 3. That means router 3 is your DR. So here definitely network type is what? Here network type is broadcast. That's why DR and BDR is here. Otherwise on point to point link DR and BDR election will not happen. Yes or no? Now let me check the network type, guys. First of all let me check that how many command engineer have run in OSPF over here. So IP OSPF network point to point OSPF 1 router ID is this one and network. Okay, everything is fine. Now so IP OSPF interface F0/0, and here we can say include and network. No, let me check the command on router number 1. When I am running this command, so it is showing me network type. So here I can say include capital N and capital T type, network type, include network type. Okay, so here I have put interface twice. So IP OSPF interface F0/0 include network type. So here let me change it. Network type is point to point on which interface? On F0/0. Okay, it's fine. On F1/0 also let me check network type. So here network type is also point to point. Okay, on router number 2 everything is fine. Yes or no? I have checked the configuration manually. Now I don't think that there is any misconfiguration on router number 2. Now let me take you on router number 3, because problem is router 2 is not installing 10.1.2.0 network in their routing table. So let me take you on router number 3 directly, and here so IP OSPF neighbor. So neighbor is 2.2.2, and here you can see DR and BDR election is happening right on link which is connected with router 1 and router 2. That means I think there is some misconfiguration. So run section OSPF. So here engineer have not configured the network type. So let me check the network type on F1/0 which is connected with router 2. So IP OSPF interface F1/0, and here we can say include network type. So network type is what? Broadcast. Okay, so here network type is what? Point to point, and here network type is broadcast. So as you know, network type, to become a neighbor, network type must match. So here also I need to configure what network type? Point to point. Let me do it first of all. Config T interface F1/0 IP OSPF network type point to point, and now if you will verify, so you can see network type is point to point. Now there will be no DR and VDR, so IP OSPF neighbor. So yes, you can see now DR and VDR is not, DR and VDR election is not happening over here because network type is this one. And so IP OSPF database, in the database you can see LSA 1 to LSA 3 are there. Now LSA 2 is filtered. On router number 2 also you can verify it. So IP OSPF database, now you can see LSA 2 is not there. Okay, now so IP route OSPF. So 10.1.1.0/24 is here, right? Reachable via 23.1.1.2. Now on router number 2, let me check router have installed prefixes in their routing table or not. So IP route OSPF. So here also you can see 10.1, 10.1.1, 10.1.1.0 is also there, and 10.1.2.0 is also there, right? Now let me verify on router number 1. So IP route OSPF done. 10.1.2.0 is there now. Now PC1 can ping to PC2 or not. Let me verify. Ping 10.1.2.1, sorry, 2.10. From PC number 2 I can ping. Okay, ping 10.1.1.10. Still I am not able to ping. Let me check the IP address of PC1, guys. No, there is some problem with this PC. Okay, we can ping from router interface because there is some problem with PC. I am not able to take access of PC1. No problem. Let me close it and then let me try once again. No, I am not able to take. So what I can do, I can ping from router 2. Let me check the connectivity from LAN interface. Ping 10.1.2.1 and source is 10.1.1.1. So yes, you can see now I am able to ping. Now LAN are able to communicate with each other. Okay, so this is solution of first issue. Now second issue is router are advertising WAN link in OSPF. Okay, so on router number 1, if you will check routing table, so IP route OSPF. So see, in the routing table, router have installed 23 network also. 23 is your WAN, right? So why router is advertising these network guys in OSPF? Here we don't need to advertise these network because our concern is end-to-end connectivity. End-to-end connectivity, yes or no? So here if you want to filter these prefixes in routing table, what we can do, we can run command IP prefix separation, right? We can separate the we can suppress the prefix. Okay, for that I need to run command on the interface f1/0 IPOSPF prefix separation. This command, once I will run this command, router will remove 12.1.1.0 network from their update. So now router number 3 is, router number 3 have installed 12.1.1.1 network also. But suppose there are lots of WAN link, so there will be lots of prefixes in their routing table. So I need to suppress WAN prefixes. So let me run this command. After running this command, now if you will check the routing table of router 3, you can see it. Soon router is going to filter this network. Or what you can do, you can run clear IP OSPF process command, say 1, yes, and now show IP route OSPF. Okay, so IP route OSPF. So I think I have run this command on F1/0. Okay, so it's fine. Then why router is still learning 12.1.1? Because router 2 is advertising. So on router number 2 F0/0 and on F1/0 we need to run same command. So let me take you on router number 2 guys. Config T interface F0/0 IPOSPF prefix suppress and interface F1/0 IPOSPF prefix suppression. Right now on router number 3, if you will check routing table, you can see 2L network is not there. Yes or no? In the same way on router number 3, I need to suppress 23 network. So interface F1/0 IPOSPF prefix separation. Okay, now on router number 1, if you will check routing table, so IP route OSPF, now you can see only 10.1.2.0 network is there. Okay, so problem 2 is also solved. Now last problem is router are sending OSPF message from LAN interface. So on router number 1, if you will debug IP OSPF, let's say hello packet. So you can see router is sending hello message from F1/0 also and F0/0 also. But why router will send any update message or hello message from LAN interface? Yes or no? Because on LAN router don't need to form neighborship. There are LAN user. So let me disable debugging first. And if you want to stop the update on LAN interface, you have to configure that interface as passive interface. So let me take you in router OSPF 1 and then we can say passive interface fast Ethernet 0/0. In the same way on router number 3 also we need to run this command. Interface F0/0, not 0/0, router OSPF 1 and passive interface fast Ethernet 0/0. Now if you will enable debugging, debug IP OSPF hello, so it will send hello message from F1/0 only now. So now everything is fine here guys. So now you can see it is not sending any hello message from which interface, from F0/0 interface. Done. Let me off it, all, and so IP route OSPF. Now OSPF is working fine, everything is fine. My LAN user are also able to ping each other, and we have filtered the WAN IP address as well from the routing table 10.1.2.1. 1 and source is 10.1.1.1. You can see. Okay, so this was a small troubleshooting of OSPF. If you are a network engineer, these these troubleshooting command can help you a lot to troubleshoot the network in real time. Okay guys, that's all for today. If you have learned something from this video, please hit on like button. If you have not subscribed this channel till now, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye guys.